Surface areas and volumes.
We revised the formula of surface areas and volumes of 3D figures we have already studied before. So the formulas we discussed, and in the last lesson also we discussed how to find the surface areas of combined figures. If we combine two 3D figures, how to find the surface area. Some example questions we discussed, and today also we continue from there, from the exercise of combination of 3D figures, their surface areas. Okay, shall share my screen. Question number 8. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. Okay, question is given like this. From a cylinder whose height is 2.4 meter square and diameter 1.4 centimeter square, we can draw some figure. 2.4 centimeter height and 1.4 centimeter diameter. Okay, so figure will come almost like this. Okay, a cylinder with 2.4 centimeter height, 2.4 centimeter height, and diameter is 1.4 centimeter. So what will be the radius? What will be the radius?
0.7.
0.7. Okay, 0.7 or 0.7 meter will be the radius of the cylinder. Then what is told? A conical cavity of the same height and same diameter is hollowed. Hollowed means tolakchu എന്നുള്ള അർത്ഥത്തിലാണ്. Diameter is hollowed out. Okay, so we want to take a conical cavity with the same diameter. Same diameter means the base diameter of the cone will be same as 1.4 or same as the cone cylinder, and the height of the cone is again same as the cylinder, that will also will be 2.4. So that means the top vertex of the cone that will touch the base of the cylinder if we keep it like this. Okay, so this is the picture. So that is taken out. That cone is taken out from the cylinder. Suppose this cylinder is made with wood cylinder. So that is such a cone is curved out, taken out from this wooden cylinder. So you can imagine the picture like this. Then what we have to find the total surface area of the remaining solid to the nearest centimeter square. We want to find the total surface area of the remaining solid. So we want to make some relation, which all areas we want to find to get the result, which all area. Sometime maybe something may be needed to subtract, sometime may be add. How we can write?
CSA of cylinder minus.
CSA minus. Oh, what will be the surface area? No, not volume, just a surface area. So what will be the in the outside there will be some area, and inside there will be some area, right? Inside this is like a how we can say some glass or something. Okay, suppose this is made with some wood or some glass. It's like some glass we drink water. We can imagine like so. So what will be the surface? Entire surface through inside and outside. That wall means the total surface area. I need to subtract. We want to add the inside the cylinder. Some surface is coming, right? Some surface is coming. Suppose we paint all the surface of this shape. So we want to paint inside also, right? So what will be the total surface area? And two ways we can write. Okay, two ways we can. One is TSA minus the base area, then plus. Okay, I think I shall write here. Okay, what will come is we can write like this. Find the total surface area of the remaining solid. The total surface area. I think TSA enough. Okay, TSA of remaining solid. Remaining solid. That's what we want to find out. This will be equal to, in two ways we can write about the cylinder. One way we can add a CSA plus one base area. One base area. CSA of cylinder plus one base area of cylinder. Then you also want to add what we want to add? CSA of cone. CSA of the cone. This first sum, this is same as first sum. You can also write like this: TSA of cylinder minus
base.
yes, minus one base area. One base area is simply base area of cylinder. Okay, so for a cylinder there are two base. So curved surface area plus one of the base area will be same as total surface area minus base area. Both will be same. So in any way you can write. So I think it is clear. Okay, then curved surface area of the cylinder, what will come? Curved surface area of the cylinder.
2 pi RH.
2 pi RH, okay. Then base area of the cylinder.
Pi R square.
Pi R square. Then curved surface area of the cone.
Pi R.
How?
Pi R.
Pi R. Okay. Then substitute the values 2 pi into R.
Pi R common.
Yes. Pi R is common. Okay. From here itself we can take outside. Okay. So pi R take outside. So 2H plus R plus
L.
L will come inside the bracket. Now we can substitute. So pi into R is, radius is 0.7, right? 0.7, and inside the bracket 2H. What will come? 2H. 2 into 2.4. Okay. In next step we can simplify it. Plus radius again 0.7 plus L. L we have to find out. This is a question I told in the previous question I told. In some question we may have to consider the right triangle inside a cone. Inside a cone there is a right triangle. The sides are, one is lateral slant height, one is height of the cone, and one is the base radius of the cone. So this will form a right triangle. So using Pythagoras theorem, if one is missing, we can find out. So here H is given. H is same as the height of the cylinder. 2.4 will come. Okay. So radius is given. So we can find out L. I think the right side we can do that. Okay. So from this right triangle, we can make a relation like this. L square is equal to R square plus H square. You can substitute given value, then we will get the value of L. Okay. R is given. L square is equal to R is given 0.7. So 0.7 square plus H square. H square is 2.4 square. So what will come? L square is equal to 0.7 square is
0.49.
Yes, 0.49 plus 2.4 square is
5.76.
Yes, 5.76 will come. 24 square is 576. So 2.4 square will be, you want to put point 2 placed left. Similarly, 0.7 square, 7 square is 49. So 0.7 square will be, you put point 2 placed left. Now you add L square is equal to, adding this, what will we get?
6.25.
6.25 will come, right? 6.25 will come. Now L is equal to root 6.25. What will come? Root 6.25.
0.25.
0. How much?
2.5.
2.5 will come. 2.5. We know square root of 625 is 25. So 6.25, the root of 6.25 will be 2.5. This much centimeter. Okay. So that value we can substitute here, pi RL. So pi R is taken outside. So L here, L is here, L is 2.5. Okay. So next step we can do this. Okay, pi into 0.7 into inside the bracket 2 into 2.4.
4.8.
4.8 plus 0.7 plus 2.5.
3.2.
3.2 will come. Okay, next pi into 0.7 into what is the sum? Their sum is 8 will come. Okay, 8 will come. Now I think in this step itself we can substitute pi. Okay, pi is 22 by 7. So can we cancel 7 and 0.7?
Yes.
So how much times?
10 times
0.1.
0.1. 0.1 times will come, right? So just think like you just think like this 0.7 into 10, that will become 7. So same time there will come 110 in the denominator. So 7 in 7 one time by 10. So that will make 0.1. Okay. So next step 22 into 0.1 into 8. What will come?
2.2 into 8.
2.2 into 8. Okay, that's fine. 2.2 into 8. What will come? 2.2 into 8.
17.6.
17.6. Just try, the students. What did you get? Other
Yes.
student? Same.
17.6.
17.6.
71.7, right? 17.6 unit centimeters.
Centimeter.
Okay. So it is said to round the number. Find the total surface area of the remaining solid to the nearest centimeter square. Nearest centimeter square, we
18.
want to round it. So
18 centimeter square.
18 centimeter square. Okay, we got the final answer. 18 centimeter square. Okay. So in such questions, the problem is to understand the picture. And after understanding the picture, to make the relation, the surface area, the required surface area, how to find. Then the next step is you want to memorize the formula. You want to apply the formulas without any confusion. So many formulas are coming together, the volumes formula also. So don't be confused. Okay, study very well. Okay. So fifth question. Fifth question, measurements are not given. We are not doing now. So here the measurements are not given, only given using algebra. We want to use this L only, no length in numbers. So the same way, the picture will come. Okay, here the cut out. What is cut out? A hemispherical depression is cut out. Yes, almost the figure comes almost like this figure. But here the cutout, what is cut out here? A hemispherical depression. And in the question we discussed, here a cone is cut out. That's the only difference. The figure comes almost same way.